Hello, good morning everyone. I am Sravanthi from Department of Aeronautical Engineering. I am here to teach flight vehicle design subject which will be coming in 7th semester. So the first topic is introduction and phases of an aircraft design. So in this subject, the first module, we'll just see what are the concepts that are involved in the first module. So first module consists of overview of a design process, the different phases of an aircraft design, and mainly we will be talking or concentrating about the aircraft conceptual design process here and what are the different parameters that are going to be related in that stage, and we will be doing about the sizing. All the different estimations are going to be made in this particular first module, and the textbook that we can refer to the subject is the Raymer, Aircraft Design by Raymer. So a design would look more like a drafting, or more it is a computer aided drafting, we can say. Then design is something that it is going to be done by creating a geometric description of a thing that we build. So somehow the designer makes sure that when he's designing, the landing gear is going to fit, right? Then the fuel tanks are near the CG levels, and he also designs a structural member such that it is very simple and light in weight, because weight is an important factor in an aircraft. So therefore, design is not just a layout. We cannot define design by saying that it is a layout, but it is also an analytical process where it is used to determine what should be designed and how the design should be modified in order to meet requirements. Now, requirements are again given by different ways, like by customers or by sizing specialists. So, accordingly, the design is an analytical process, right? So, therefore, we have different definitions for the design here. For aircraft design, according to the designer, to him the design is a completely new approach, right? He is going to come up with new ideas. Then for him, the definition of the design or the design would start to him by having a new concept in his mind. Then for a sizing specialist, to him the definition of the design is by taking the estimation of the weight, right? So I cannot go and design an aircraft without having a knowledge of what are my first estimates of an aircraft gross weight or what is the fuel weight. So therefore, to a sizing specialist, the weight or the initial estimates of what an aircraft is going to be is his definition. Then to a customer, maybe a civil or military, then whatever the requirements that are been given by the customer is the definition of a design, or from where the design was going to be started off from. And all the definitions are right. Then the design wheel, here we can see a design wheel approach, right? So first I start from the requirements, where I consider or the customer is going to give me some requirements of how my aircraft need to be designed, right? For this, maybe different sizing or different, it has been taken from different trade studies. Then for that requirements to be met, I go and have a different approaches or concepts, right? Different, maybe I have different concepts. Then I would go and choose that particular concepts, or I narrow down some concepts which are better in meeting that particular requirements that are set, right? Then once the concept or that idea is finalized, then that particular concepts are going to be gone for analysis, right? So different analysis are be done, whether the requirements are going to meet or not, whether the aircraft is going to look like what the designer has thought of it. So all these are a iterative process. It's an iterative effort. Then we have two main key requirements for the design. One is customer specification and the other is airworthiness requirements, right? So customer specifications is where in terms of civil or in terms of military aircraft, if we see. Then for a market, it is we are talking about the civil aircraft here, where I go and design or manufacture an aircraft, and that aircraft is going to be in service like for about 10 to 15 years, right? So therefore, I have a complete a knowledge of how the aircraft should look like, or in a period of 10 to 15 years, maybe let me have or let me consider a better technologicals, or let me implement such technologies in my particular aircraft, maybe in terms of material, maybe in terms of glass canopy or fly-by-wire system. So therefore, for a civil aircraft, it is important or to have a knowledge of how it is going to look like in the future. And whereas for an operational requirement, this is completely for the military, right? So for the military, I don't really look for all of these maybe, but all I want is the whatever the operation that is given it has to fulfill that mission, right? So therefore I go and design, or I go and manufacture my aircraft in such a way that whatever the mission that has been given, it has to completely it has to finish that, it has to be successful in that. So that is the major criteria or aspects in terms of civil or military aircraft checking. Then comes the airworthiness, and airworthiness is where once your designs are finalized, you have done with the concept or different phases of an aircraft, then you are going for your then the manufacturing part is also over, then we go for the certification, right? So these are the regulatory bodies. Sorry. So here we are going to go for the certification of an aircraft, whether it has come out good or not. All the certifications need to be checked and thoroughly. Only then the aircraft is going on the runway, right? So, and all these are based on the previous experiences, and also to ensure the safety, because safety is an important criteria for an aircraft, and it is important task, and it is also very critical for me to ensure that aircraft meets all the safety measurements, and also it should lead to the uniformity and the standardization in reporting data. Here comes the different phases of an aircraft design, right? So the aircraft design is being broken down into three phases. First one is conceptual phase or conceptual design or conceptual stage, we can say. Then the second is preliminary, and the final is the detailed design. Right, so the conceptual stage is where the primary focus of this complete subject, right? So in this particular aircraft flight vehicle design, we are going to completely learn about the aircraft conceptual phase, right? How it is going to be designed, what are different parameters I consider, and finally how I end up and how I go into the next phase, which is my preliminary stage, right? So therefore, in this conceptual design is a fluid process. So right, so in conceptual design, what we do is, first of all, I consider what are the different configuration arrangements or sizes, arrangements in terms of size and weight, right, and performance. All these are I'm going to check. Like I'm going to have an idea of all these things about the size, weight, about its performance, about its cost, and also whether the first question is whether can an affordable aircraft be built that meets the requirements. That means what are the requirements that have been given to me by a customer, whether all these are going to be met or not when I go and design something, when I manufacture the product, whether these are met or not. If not, then if not, let me relax the requirements. Relax the requirements is where the customer has given so many different approaches, or he has so many inputs. And when the designer starts deciding according to the inputs, maybe the aircraft or maybe the wing is large, or maybe if the overall aircraft is going to be very large, then it is not going to get that efficiency what it should have got when if only you might have relaxed the requirements. So therefore, the designer would specify the customer to let relax the requirements, and uh, maybe let me not use some of all the specifications that are given by the customer. Let me relax some of this, then we get a better output. Better aircraft is going to be designed or manufactured, right? So that means in this particular conceptual stage, we come up with so many new ideas, or I have many concepts, many problems that are going to emerge, right? So there are, then we check for the feasibility of the product, right? So I have n number of designs or a number of ideas to it, then therefore I narrow it down, and I check which design is better or which concept is better approach for my problem statement that is given to me, right? So therefore every time, so each time the design every time when you come up with a new idea or new concept, then every time you have to go through all certain things, all certain parameters as such, the new gross weight. You have come up with an approach where for that particular approach you have estimated, the sizing specialist have estimated his gross weight, or he has estimated his fuel weight or wing size or other things, right? But when you have too many ideas, then every idea that you come up with, every time you need to cross check what's the gross weight is going to be, how much of the amount of the fuel is going to be consumed, or what are the wing size or other engine size or any other thing, right? Every time you come up with a new concept, then every time you estimate, or the sizing specialist is going to run again and again, make so many iterations and come up with a rough idea of how an aircraft would look like in a conceptual stage, right? So therefore, all we do in conceptual stage is we establish a concept feasibility. I narrow down all the different concepts and I conclude that yes, this is the concept that I'm going to follow in designing my aircraft. according to the requirements that have been given, right? Then carry out the initial sizing and layout to it, and then give the estimate masses or performance and cost. Cost is also important when I am at the initial stages. I need to have a idea of what is the cost of an aircraft, what is the weight of it, and what is the performance wise the aircraft is going to look like. Then we have preliminary design, right? So in this preliminary design, conceptual design ends when you have a rough idea of what your aircraft is going to look like, right? And you have concluded with how your major components, where it is going to be, right? So that is where your preliminary stage begins, where the major revisions are done, right? So therefore you're not going to revise any of the major things. So that is where we call freezing the configuration. Only a minor revisions are going to be done in this particular stage, right? And everything is going to be designed and analyzed, and you carry out some tests here, right? That means whether, like, I understand now, do I want a Kannada configuration or do I want an active configuration? All these we have completed in a conceptual stage. So in my preliminary stage, I am going to go and check with every specialist, like if we're talking about propulsion, or he is going to design and analysis, he is going to do his part. Then if it is aerodynamic, right, all different specialists in their different areas are going to go for their design and analyze them and check whether this is going to be correct or not, right? And also the other important activity that we do in our preliminary stage is lofting. Lofting is a mathematical modeling of the outside skin of the aircraft with sufficient accuracy. That means here I am not the only designer, or I am not the only specialist who is going to design the entire aircraft, and so therefore it is going to be designed or analyzed or run test in different locations by different specialists, right? So therefore everybody need to have a mathematical approach of how the different components are going to be assembled finally. So that is lofting. Then the last stage is the detailed designing stage, right? So once we have a rough idea of how it is going to look like, then we have also designed the major components. Then each individual specialist has gone through their analysis, and once all these things are done, once all the major components have been designed, analysis, and some tests are being developed, then we enter into a detailed stage where you go and fabricate. One thing is you go for the production stage where you're going to fabricate from the small sub assemblies to the entire aircraft. Also, we go and the major component, whatever we have designed and analyzed, we are going to design the sub assemblies, right? You have considered a complete wing box, right? In that, what are the sub assemblies that we have, either ribs or spars or skins, whatever, all the individual small sub assembly components that we have, every individual component is going to be designed, right? So that is your detailing design, where I start off with the small, even a very minute component is going to be designed, analyzed, right? So all these detailing things are being done in the final stage. And once when all of these things are done, then we go for the production, where I start fabricating from the small simpler one to the final product, right? Then they're going to be tested. Then finally we go for the certification process, where I have to check my aircraft for the airworthiness requirements or any other certification that we need to follow, and ensure that yes, the aircraft has gone for all the certification and it is good to go. So that is the different phases of the aircraft: conceptual, preliminary, and detail. And the next is your aircraft conceptual design process. So here we are going to completely talk only about the first phase, right? What are the all the things that are going to happen in the first phase of aircraft, which is conceptual design, right? So here the first thing is the design requirements that we have already said, right? So first of all, I consider or I take the requirements from the customer, right? Customer is going to give me the requirements, or a company is going to generate the requirements. Guessing that these are the future customer requirements maybe, right? So first is either the customer is going to give them or the company is going to give it, keeping in mind that that would be the future customer specifications, right? So that would be the first thing. Then then I start with understanding what are the different technological availabilities we have, right? So one is where I talk about the nearest future or a distant future, right? if we are going to design in a nearest future, then it would be, I don't want to go and look in the future how technologies are going to be developed, right? So I'm only going to consider the existing technologies or existing engine or existing avionics and all. I go with that only, right? So, but if we are talking about the distant future, then the designer, right? Then the designer is going to look into the emerging technologies, right? So, keeping in mind what could be the future technologies, then I go and implement such things. So that is my technological availability. Then this design requirement parameters may include certain things, that is like range, right? So it could be range or takeoff and landing distances, right? Then it could be speed of it. Okay, then it could be the maneuverability of it, right? So all these are could be the design requirement parameters, right? Then there could be other parameters also basing on the some other requirements are been given by civil and military. So that is landing sink speed or the stall speed or the reserve fuel, right? So all these parameters are also being taken into the consideration in this particular stage, right? So then we come up having a good conceptual sketch, right? Now, what is a good conceptual sketch? A good conceptual sketch is an aircraft which would have a approximate wing and tail geometries, proper shape of the fuselage, or proper internal locations of the big assemblies like maybe a few fuel tanks or engine or landing gates, right? So all these, I have an idea of how all these are going to be fitted, right? So that makes a good conceptual sketch, right? So then once you have an idea of how your sketch is going to be in your initial stages, then we go and start having a or estimating your sizing of an aircraft, right? So that comes the word sizing. So this is the word sizing we are going to be introduced here, right? So sizing means uh, the person is going to the designer, the sizing specialist is going to guess the estimates of an aircraft, right? So that would start from the aircraft weight or the aerodynamics and the weight of it, right? So by comparing the previous studies, right? So he would guess it by the previous studies about the aerodynamics and weight of the aircraft. Then these estimates are being taken to understand the total required weight and total fuel weight, right? Because these are the important parameters to me when I'm in the initial stages. I want to understand what is the complete weight of an aircraft or how much fuel I'm going to utilize for that particular mission to me, right? So therefore, I start with the total required weight and total fuel weight. I take up that and I understand for that particular design for particular mission process how much it is going to be, right? In the initial stages, that is called sizing, right? So that is the initial or the first order sizing that we do, right? Then we come up with the initial layout, right? So this is called initial layout, where I have considered or where I have or I have knowledge about what is the weight of an aircraft, how much fuel it is going to take, or what are the different internal location where they are going to be placed, right? So all these things I have a basic knowledge of how my layout is going to look like. So this picture we can see this, right? So how your initial conceptual phase design is going to look like, right? Now when you have an estimation of this, then I go and analyze things, right? I need to do initial analysis of the aerodynamics or the weight or the propulsion characteristics, right? So these analyses are done in order to determine whether they are meeting this particular first order guessing or not, right? So whatever we have done here, whatever we have come up with this particular sketch, this sketch I need to analyze such that what are the requirements that are given to me, did I met them or not, right? So these things are going to be checked here. Then the sizing and optimization is also done, right? So you do optimization for a lighter one or a simpler one, right? But at a highest development of risk, right? So all these are going to come. So you try to optimize things and check. Then again, after many number of optimization, we get a revised layout, right? So that means therefore here we are going to iterate a lot of things for a lot of times, right? Iteration is going to happen, right? So finally we come up with the revised layout. The revised layout will give you all the revised sizings, right? The revised weight or the revised fuel weight of it, right? So that is going to be looked in this particular revised layout where I have, yes, now this is my revised picture where this is how the estimates are going to look like, right? And then for that, the analysis has been done by different specialists again, aerodynamics or propulsion or stability and control, structure, and the cost of it is also, you have an idea of now how the cost of it is going to be, right? Now all these refined sizing and performance are being optimized. They are going to check for its performance levels. They are going to check for the design mission process, right? So that is where we end up with the conceptual stage, right? Where I have finally refined and I have an idea of all the basic or the initial sizings to me, and I've also checked that yes, this is going to be meeting the requirements that are being given by doing many iteration and by optimizing, right? Then that final product that is going to come here is being sent to the preliminary stage, which is the second stage. So the next is the sizing from conceptual sketch, right? When we understand what are the different phases of an aircraft and mostly the conceptual phase of it, then we have to go and do the estimates of an aircraft, right? So for an estimates of an aircraft, now these actual design requirements must be evaluated against many number of candidate designs, right? Each of them have to go through a design, analyze it, then size it, then get optimized and redesign if it is required. How many number of times you want it, right? So until you get what do you want, till that particular time I'm going to redesign or iterate it, right? So in between all of these things, we are going to, in between these extreme design analysis procedures, we lie the methods that are used for most conceptual design activities, right? What are they precisely, right? So the first one is the takeoff weight buildup, right? Now I want to understand what is the gross weight of the aircraft, or what is the crew weight of it, or what is the payload weight, or different weights, right? I have to initially estimate a few parameters. So one of them is the takeoff weight buildup. And takeoff weight buildup, W naught, we say. W naught is the design takeoff gross weight, right? So it is the total weight of the aircraft as it begins the mission for which it was designed, right? That means the initial stages. In my initial stages, I consider that W naught is the takeoff gross weight, right? But it is not necessarily that it is going to be the maximum takeoff weight. Why? Because in my military aircrafts, I'm going to take away maybe different payloads, right? So then your gross weights are going to change, right? So it is not necessarily the maximum takeoff weight, but it is the initial design takeoff gross weight denoted by W naught, right? Then now this W naught is been broken down. Here we have a formula that has been given. Design takeoff gross weight W naught is equal to the sum of the crew weight plus sum of the crew weight, payload weight, fuel weight, and empty weight, right? Now, what does it mean by crew weight? Crew weight is where I have a 3 or 4 crew members in it, and that is known, right? It is not like I don't know what it is. I don't know how many members are going to be, but this is the known constant, a known figure, which is a crew, right? So this is known. Then the next is the payload, right? A payload means maybe a cargo, maybe passengers, maybe a weapon drop or whatever, right? So this is also a known factor, right? So these two things are the known constants, which are crew weight and payload weight, right? Then we come to the fuel weight, right? Now, how much amount of fuel is going to be spent for that particular mission, right? So that now that weight of the fuel is unknown to me. I have to go and determine it, and that determination is based on your mission specification, how much amount of fuel you are going to be spent, and if there are any drops, right? If you have a weapon drop, or if I have a refueling, right? So all these are different parameters when you talk about the fuel, right? We need to consider. Then the empty weight, right? Empty weight is like structure, materials and all, right? So therefore, my W naught, the total design gross weight, is going to be crew weight. It is being summed up for crew, payload, fuel, and empty weights, right? Now, therefore, in order for me to have a simplification of the fuel and empty weight, let me consider the fractions of it, right? So let me just write in terms of a fraction for my ease of simplification, right? If I simplify these things, then it would be easy for me to understand, or estimate the fuel weight fraction or empty weight fraction, right? So therefore, if we go and write in that fashion, then my W naught is going to be W crew plus W payload plus WF by W naught into W naught, WE by W naught into W naught, right? So therefore, I can rewrite my gross weight as W naught is equal to crew plus payload by 1 minus of WF by W naught minus WE by W naught, right? Now it is easy for me to go and estimate my fuel fractions, and E is your empty weight fractions. So first we are going to estimate the empty weight fraction, which is WE by W naught, right? So WE by W naught, which is an empty weight fraction, it can be estimated from statistically from the historical trends, right? So historical trends is where we can see graph is missing. We will be seeing in the next slide maybe, right? So we have a graph, a historical trend graph that should be there here. It is missing. We will be seeing in the next class, right? So for that, a different type of the aircraft's trend is being shown here, right? Trend with respect to the weight, with respect to its WE by W naught, right? A fraction. That is already it has been given. A set of values have been given to it, right? So that would vary from about 0.3 to 0.7, something like this. It is going to look like. Okay, with respect to weight fraction, I have for a different type of an aircraft, maybe for a jet aircraft, right? Maybe for a sailboat, right? We will see in the next class this picture, right? So for a different type of an aircraft, I already have a data of how much is my WE by W naught basing on the historical trends, right? So table is given to you. So WE by W naught is showing A into W naught power C into K of Vs, right? So that is where my A and C are constants here, right? So the table is showing you the constant numbers of different type of an aircraft. For example, if your aircraft is a sailplane unpowered one, then my A is 0.6, but C is in the exponential, a negative number. So therefore, whenever we have this particular in an exponential number in negative, we have a decremental of it. Okay. So as such, we can also see a jet trainer or jet fighter aircraft, which we are going to utilize in our numericals in the next classes, right? So for a jet fighter aircraft, then my A is going to be 2.34, then C is minus 0.13, or if it is a bomber aircraft, then it is going to be 0.93, or the C is minus 0.07, right? So already the predetermined values are been given considering the historical trend of it, right? So therefore, these exponents are small negative numbers, which indicates that your empty weight fraction decreases with increasing of the takeoff weight. Okay. Then we have a fuel fraction estimation. Right, fuel fraction estimation. We said it is a WF by W naught. Right. So it's WF by W naught. Now, when I say fuel fraction, there may be a different type of fuels. Right. That means one is mission fuel, which is the aircraft's fuel supply available for performing the mission. But apart from this, we also have other name, which is the reserve fuel. Reserve fuel is means where I have this particular fuel that has been reserved for emergency purpose, or somewhere maybe if I want to, if I don't have a airport which is closed, or if I don't have a runway where I can park my aircraft, then I need to make a loiter, right? So, and that loiter also I need to make it for 20 to 30 minutes. That is the standard timing that I have to maintain it, right? 20 to 30 minutes of loitering has to be done. That means I have a separate range that has been given to me, right? Additional range is given to me for a loitering of 20 to 30 minutes. That is in terms of emergency. Therefore, I reserve the fuel, right? So that is reserve fuel. And also we have another fuel, that is a trapped fuel. Trapped fuel is where the fuel that is not being pumped out of the tanks, right? So that is a trapped fuel, right? So therefore, when we're talking about the fuel fraction estimation, I need to know about the mission, right? What is its mission, right? Where it has to be flown, or what is the purpose of it, if it is a civil aircraft, if it's a military aircraft, the purpose of it, the aerodynamics of the aircraft, and the how much amount of the fuel is going to be consumed according to the mission that has been given, right? So basing all of these things, we are going to estimate the fuel fraction. Then when we say fuel fraction, that is based on the mission. So therefore, we come up to a new concept called mission profiles, right? So I need to understand what is my mission profile, right? So we have different mission profiles. One is a simple cruise, the other is air superiority, then there's low level strike and strategic bombing, right? So simple cruise, it looks simple. I have a takeoff, right? Takeoff, I climb, then I cruise, right? I cruise for about 300 nautical miles. Then I descend, I have a loitering, then I have a land, right? So that is a simple cruise. So simple cruise is being used for many transport and general aviation designs, including home-built aircrafts also, right? This has been sized to provide a required cruise range, right? A required cruise range is given, and it is going to return to its base only, right? It is going to return, and for any safety purpose, like if for any emergency cases, then I might want an extra fuel. For that extra fuel, I want extra fuel because I need to loiter for 20 to 30 minutes. So therefore we have an additional range that is been given to it by a sizing specialist ensures that the sizing of it is being given clearly, right? The estimates are already done, right? Then the next is the air superiority, right? In the air superiority, what we see, I have a takeoff, I have climb, I have cruise, then I have combat, then I have a weapon drop, right? If I'm dropping the weapon, then well and good. If I'm not dropping the weapon, also again the sizing specialist has to ensure that it has to return safely. And therefore, again I have a climb, I have a cruise, then I have a loiter, then I have a land, right? So that is air superiority. It includes cruise out, combat consisting of a certain number of turns or number of minutes at maximum power, right? Weapon drop, a cruise back, and a loiter, right? So second cruise segment is identical to the first one, which indicates that it is going to return to its base, right? So we have different type of mission profile where I'm not going to return to the base because it would only give me additional range to it, additional fuel to it, and additional weight to it. So therefore, we have the other such are strategic bombing where I don't return to the base. I might return to a friendly airport or nearby, right? So the third is a low level strike mission, right? So low level strike machine is this here. I have a takeoff, then I have a climb, then I have a cruise, loiter, then I have a weapon drop, then I have a climb, cruise, loiter, and land, right? But what's the difference between the low level strike and a simpler air superiority is I am going to be in a very 100 feet or 150 feet only, right? I'm not going to raise my higher, I'm not going to go to a very high levels of altitude. This is to only improve the survivability when I have enemy attacks, right? I don't want to be in their radar, so therefore I maintain low level of altitudes, right? But having this condition, right? So when you have a low level strike mission profile, then the disadvantages that I have is I definitely need to be at high speed flight only. My range is going to be same, but I lose my aerodynamic efficiency, right? So therefore my L by D is less. I have a efficiency that is being decreased in terms of a low level strike mission profile, right? Then finally we have strategic bombing, right? In strategic bombing we have one parameter that is R. R is refueling, right? So first of all, I take off, I climb, I cruise for about 2000 nautical miles, say, then again I refuel, right? Now from where is this refuel coming, right? If I have, why am I doing refueling? Because I want to increase my range, right? In order to, now this is for a long range mission purpose, right? So in order for me to have an additional range, then I need to have an extra fuel supply, that is refueling, right? So I have an aircraft tanker that is going to supply me some fuel. So again I refuel, then again I cruise, then I have a weapon drop, then I climb, then I cruise, then I loiter, and I land. And I don't necessarily land in my base, but I land somewhere else because it would only increase the weight of an aircraft, right? So the overall weight is going to be increased if you go and again land in the same base from where you have come up. So rather, I would go and land in a nearby or friendly airport, right? So these are the different mission profiles that we have for this simple cruise, air superiority, low level strike mission, and strategic bombing. Okay, that is all for today.
Like, share and subscribe. Hit the bell icon for more updates.